So question 2 is principally a rates of reaction question, but first there's this slightly tricky equation balancing exercise. There are two approaches to doing it. One is to make use of the fact that it's a redox reaction and use oxidation states to help you. The other is simply to treat it as any other equation and just set about the balancing exercise. So I'll just give you the second method, but if you've sorted it out using oxidation states, as long as you get the right answer, then that's absolutely fine. So the trick is to say, okay, let's decide we're going to start with one of those. Obviously you wouldn't have to write the one into the equation, but you've got to fix one of the numbers to start with, so let's fix one of those and say that means that we've got to have 3 oxygens, so we need 3 oxygens on the right, and the only way we can achieve that is by putting 3 H2O in there. So let's fix that number, and that means that we've got 6 hydrogens in total on the right, and that fixes that number as 6H+. So now all we've got to do is find how many Br2s and how many Br-, and the key to doing that is to look now not at balancing the atoms but at balancing the charges, because you can see that on the right hand side there can be no charge because they're both neutral molecules. So it's got to add up to 0, and therefore it's got to add up to 0 on the left hand side as well. At the moment, if we ignore the Br-, we've got 6 pluses and 1 minus, so it's +5 at the moment. So to add up to 0, we're going to have 5 lots of Br-. That gives us a total of 0 charge on the left, and it also gives us 6 bromine atoms on the left, and that fixes that number as 3 Br2. Okay, now the rest of the question looks like one of these very open-ended things with a big scary empty space to fill in. But when you look at it carefully, you'll see it really isn't, because it tells you what the things are that you're required to do. So it gives you a lot more help than you might think at first glance. So first of all, we've got to use the results from the experiments to draw conclusions about the kinetics. The kinetics means anything to do with rates of reaction, but particularly it's going to mean orders of reaction and therefore the rate law, and in turn the rate constant, but it tells us that explicitly anyway. Okay, so there are 2 experiments, and clearly you're going to need to use both of them. So the first has this rate versus concentration graph for BrO3-, and it looks like that. So the important thing to remember is that that's characteristic of a first order reaction with respect to BrO3-, because the rate is directly proportional to it. Now the tricky part is that in order to explain that, you have to say that because the graph is a straight line passing through the origin, or passing through 0, 0, that's how you know that it's first order. If you just say, from the graph I can see it's first order, they'll think you guessed. So you've got to say, because this graph is a straight line passing through the origin, that shows that it's first order with respect to BrO3-. That's all you can get from that experiment. To get the orders of reaction for Br- and H+, you've got to look at the data, the initial rate data in the second experiment, and it's fairly straightforward. If you compare the first and second experiments, you can see the only difference in concentration is that Br- was doubled. I'm going from the first to the second. If you look at the rate, that was also doubled. It changed by the same factor, and therefore it's first order with respect to Br-. If you compare the first and the third experiment, so 1 and 3, you can see that this time BrO3- and Br- stayed the same, but you doubled the concentration of H+, and if you look at the rate, you'll see it actually quadrupled. Okay, so the rate increased by the square of the factor that the concentration changed by, and therefore it's second order with respect to H+. Okay, so taking all those together, we've got first order for BrO3- from the graph, first order for Br-, and second order for H+. So the rate equation, remember, always has the form rate equals K times, and then some function of the concentrations, and in this case it's BrO3 minus, okay, first order, let's just get rid of this so we can see that clearly, times Br minus, again first order, times H plus squared. And that needs to be written down. Doesn't matter what order you put those in, so long as you get the right powers in there. The next step is that you've got to rearrange that so that you can solve for k. And that's easily done. Remember, to rearrange something like that, you just say, right, this is what, this is what I've got to get rid of to leave k on its own on this side. And the way you move something around in an equation like that, remember, is move it diagonally. So it's on the top line on the right, it will move to the bottom line on the bottom, on the left. So you get rate divided by BrO3 minus times Br minus times H plus squared is equal to k. And then you can just plug your numbers in. So that's equal to, if you take, for example, the first experiment, you can take any of them, but take the first experiment from the table, that's equal to 1.19 times 10 to the minus 5 is the rate, divided by 5.0 times 10 to the minus 2 times 1.5 times 10 to the minus 1 times 3.1 times 10 to the minus 1 squared. Be really careful, because it's very easy to put the square in there but not actually to do it in the calculation, and obviously that will mess you up. So make sure you really do square that term. So times 3.1 times 10 to the minus 1 squared on the bottom line there. And if you compute that, you should get 1.7 times 10 to the minus 2 is the value. And then we've got to get the units of k, which you can either work out by remembering that the units of rate are moles per dm cubed per second, and dividing that by moles per dm cubed times moles per dm cubed times moles per dm cubed squared. If you're not comfortable doing that, the cheat method is to learn the recipe. And the recipe, remember, is that you find the overall order. So the overall order, and call that x. And the overall order in this case, remember, is the sum of the individual orders is 2 plus 1 plus 1, which is 4 in this case. And the units of k, units of the rate constant, are moles to the 1 minus x, dm to the 3x minus 3 seconds to the minus 1. So it's a slightly odd looking equation, but if you learn that, you can just plug the number straight in. So 4 goes into there, and you get 1 minus x is minus 3, so it's moles to the minus 3. dm is 3 4s are 12, minus 3 is 9, dm to the 9 seconds to the minus 1. And that's your answer for the value of k. And that's all you have to do for your 10 marks.